The final part of Chapter 3 is really talking about databases for physical evidence. We've alluded to the fact that there's a couple of different reasons why we have these forensic databases. One, they are used to store values for different kinds of individual or class physical evidence. So I'm going to store information from a variety of sources nationwide and create this database of all these properties for different materials. And then I'm going to use it to identify reference samples. So I want to match something in my possession from a crime scene to something in the database and say, oh, well, they have a common source. So for instance, maybe if I have a bullet casing and I can measure the striations on it, but I don't have a suspected weapon, if I can go to the database for bullet casings from different weapons and I find a match, now I can go after that suspected weapon. As these databases get larger, that's more and more possible. I can also use it, and what is really particularly important is also all of this collection of information now can be used to establish probabilities. Remember the importance of these probabilities of class characteristics and needing to use those to defend a particular analysis in a court of law or to refute a particular analysis in a court of law. So starting off now it's often called IAFAS, but it's now NGI for Next Generation Identification. So this is the fingerprint database, and this is a fairly large fingerprint database. It's maintained by the FBI, so it's actually maintained by a law enforcement agency. So criminal arrests, upon criminal arrest, fingerprints go in there. Employment checks, fingerprints will be taken and entered into the database. Customs, certain visitors have their fingerprints taken. Firearm purchasers have their fingerprints taken. So this is now a fairly large database of fingerprints. It was, I don't know if they pronounce it IAFAS or IAFAS, but now it is the next generation. So the next generation identification just kind of helped with processing it and making it a little bit, there's some additional information that gets fed into it we'll talk about in the future. And that sort of took over in 2014. And the idea is that each state has its own fingerprint identification system that they manage and maintain that they feed into NGI. Another database is CODIS, Combined DNA Index System, and this is now DNA samples from many, many individuals. For the most part, these individuals are mostly now convicts of some sort. So individuals convicted of a felony sexual offense, but there's also ones from unsolved crime scenes. So these are, it's sort of the reverse matches. Like we have unsolved crime scenes in there, and if we get a new match from somebody who's been arrested and it matches to one in there, now we can solve an unsolved crime. We have an offender index. Those are people who've been convicted of a crime, and they keep up with, a lot of times when they go into the parole system, this will be collected if they haven't had it collected before. And fairly new is starting to collect DNA from arrestees. So if they're waiting trial or detained immigrants, collecting DNA evidence from them. This was a little bit controversial in, I think, 2014, maybe it's 2016, a fairly recent case, Maryland versus King, successfully challenged the right to collect DNA from arrestees. They said, well, this is similar to fingerprinting, that this is part of a regular booking process, is the identification of the individual, and that it's fair and reasonable to collect DNA, and it's been upheld so far. It was deemed reasonable under the Fourth Amendment, and so now they've been collecting DNA from arrestees. There's also a United Kingdom DNA database and a Canada one. I'm sure some of the other countries have them as well. CODIS is really just United States. Of course, there's foreigners are in the database if they have been one of these individuals where they collected information from. Another database is NIBIN, National Integrated Ballistics Information Network. So this allows firearm analysts to digitize and compare markings made by firearms on bullets and cartridge casings. So these are sort of these striation marks that occur from different weapons. So it uses a product called IBIS that captures a microscope image and then digitizes that image and puts it into the database. So this will not do an electronic match. So the NGI will actually be able to electronically match. You submit a fingerprint and it can search for the matching ridge characteristics to pop out and say this is a possible match. That doesn't happen with this. So in this case, you can find a match, but an analyst has to actually take that match and examine that image and examine the other image and look to see, do they actually match? So it requires an actual analyst to examine to actually make the match. PDQ is a paint database, so paint data query. So this is chemical and color information of different paint layers from different paint chips. It's used a lot of times in hit and run accidents to try to figure out the make and model of the accident of the runner, the vehicle that had run off that's no longer there but left a paint chip on the car that was hit. And it's contributed to from a variety of sources. It really was originally maintained by the Royal Canadian Mounted Police, and now there's a lot of forensic labs in the US that contribute to it, and police agencies from many countries contribute to it, so that it's getting stronger and stronger. As more entries are made, obviously the identification possibilities are improved. Another one is the SICAR, the Shoe Imprint Capture and Retrieval. So it's saying it's a shoe imprint database, but it also has tire tread. So there's sort of, and it's encoding pattern features. That it comes up with codes for the pattern features, so that it's there's a system to trying to sort through different ones rather than just looking at 80,000 possibilities. It has Soulmate, which is a sole database, so it can say, this sole is the tread pattern of a Hush Puppy size 8 model whatever from this year or this range of years. Treadmate does a similar thing for tire tread pattern database. There's not that many tire treads out there comparatively. I think there's probably more shoe treads than tire treads. And so being able to match those up, again, this one is not very automated. It's more of an individual can go through and find several possible matches and then an analyst has to actually examine them. But that can be very helpful.